students, we are discussing about inventory models. So far we have discussed about the inventory models where the demand is deterministic. What is the meaning of deterministic? The demand is known to you. Hereafter, we are going to discuss a new inventory models where the demand is not deterministic, it is a probabilistic. So, the agenda for this lecture is, it is a single period inventory model with the probabilistic demand. Here the period is only one period. So, this kind of inventory model is applicable for perishable products. So, very famous problem is called Newsboy problem. So, in this class we are going to discuss about the Newsboy problem. We are going to consider three types of demand pattern. Sometimes the demand may follow an empirical distribution, or it may follow uniform distribution, or it may follow normal distribution. If for single period, if the demand follow any of these three distribution, how to find out the inventory models? That is going to be the objective for this lecture. The inventory models discussed so far were based on the assumption that the demand rate is constant and deterministic throughout the year. For the deterministic demand, we developed minimum cost order quantity and reorder point policies based on this assumption. In situation for which the demand is not deterministic, other models treat demand as a probabilistic, and that is best described by a probability distribution. What is the probability distribution? There will be a x also will be there, there will be a f of x also will be there. Here f of x is a probability. So, for each demand a probability is attached. For example, say 10, 11, 12, there will be some probability values. That is the meaning of this probability distribution. Now, we can discuss the assumptions for this model. The single period inventory model refers to the inventory situation for which one order is placed for the product. At the end of the period, the product has either sold out or a surplus of unsold item will be sold for salvage value. Here there is no concept of holding the inventory, because it is only one period. If the product is not sold, then that product is waste. A single period inventory model is applicable in situations involving seasonal or perishable item that cannot be carried in inventory and sold in future period. So, for perishable items we cannot carry the inventory for the next period. The seasonal clothing such as bathing suits and winter coats are typically handled in a single period manner. In these situations, a buyer places one pre-season order for each item and then experiences a stock out or hold a clearance sale on the surplus stock at the end of the season. No items are carried in inventory and sold the following year, because it is a perishable items. The another name for this model is famous Newsboy problem. See, the newspapers are another example of a product that is ordered one time and is either sold or not sold during a single period. So, if the newspaper, if it is not sold that day, you cannot use it for the next day. Okay. Although newspapers are ordered daily, they cannot be carried in inventory and sold in later periods. Thus, newspaper orders may be treated as the sequence of single period models. Each day is one period there. That is, each day or period is a separate, and a single period inventory decision must be made each period, that is for each day. Because we order only once for the period, the only inventory decision we must make is how much of the product to order. You need not bother about when to order, we are bothering about only we should know how much the product to order at the start of the period. Obviously, if the demand were known for a single period inventory situation, the solution would be easy. We would simply order the amount we knew would be demanded. However, in most single period models, the exact demand is not known. Even though a newspaper boy, he may not know what is going to be demand for that day. In fact, forecast may show the demand can have a wide variety of values. If you are going to analyze this type of inventory problem in a quantitative manner, we need information about the probabilities associated with various demand values. So, we need to have, if there is a forecast value for the demand, then we need to have the probability also. Okay. Thus, the single period model presented in this lecture is based on probabilistic demand. How to get these probabilities? The probabilities are arrived from the past data. For example, suppose I have considered 1, 2, 3, 4, 5, say 5 days in a week except Saturday, Sunday. We have the past data. For example, the day 1, the number of daily sales is 300. So, that has occurred for 15 days, okay. Out of 100 days, 15 days the daily sales is 300, 20 days the daily sales is 400, 45 days the daily sales is 500. So, this is the frequency, number of days sold. What is the frequency? So, 300 newspapers are sold 15 times out of 100 day. So, 400 newspapers are 20 times out of 100, 20 days the sales was 400. So, we had the frequency table. From this we can add this frequency. So, then if you say this is 100 days. So, 15 divided by 100. So, this is 15%, 20%, 45%, 15%, 5%. So, what is the meaning? The probability of 300 demand, the demand is 300 is 0.15. The probability for the demand 400 is 0.20. So, now we have the sales and corresponding probability. This is the way to arrive the probability for the demand. Now, we will take an example. Here the strawberry buying price is say $20 and the selling price is $50. Now, I am going to find out the concept called marginal profit, that is 1 unit profit. So, what will be the 1 unit profit? It is a $50 selling price minus $20 buying price. So, it is a $30. What is the marginal loss? Because your buying price is 20, that cannot be carried for the next period. So, if it is not sold, the loss is $20. By using this concept of marginal analysis, we are going to find out how many quantities has to be ordered in the beginning of the period. First, we will see what is marginal analysis. So, the marginal analysis is based on the fact that when an additional unit of item is bought, two fates are possible. One is 1 unit will be sold or it will not be sold. The sum of the probabilities of these two events must be 1. For example, if the probability of selling an additional unit is 0.6, then the probability of not selling must be 0.4, because the sum should be 1. Now, we have an empirical distribution for the demand. So, what is that empirical distribution? The possible demand and corresponding probability. So, the demand to be 10 is 15%. The highest, there is a 40% chance the demand is 12. Now, what we need to know? we should know what should be the ordering quantity for this kind of empirical distribution. Now, the demand is an empirical distribution. So, first we will prepare a payoff matrix. So, what is the payoff matrix? Suppose my demand is 10. If I stock 10 units, here I am going to write, first I am going to fill only the diagonal values. Here I have written the probabilities. So, my demand is 10, I have stocked 10 units. So, what will be the profit for me? So, 10 multiplied by 30, because marginal profit is $30, for 1 unit it is $30, if it is 30 units it is $300. Then see, if I have 11, the demand is 11 units, I have stocked 11 units. So, what will happen here? The payoff will be 330. The demand is 12, I have stocked 12 units, 360. The demand is 13, I have stocked 13 units, it is 390. Now, look at this category here. What has happened? My demand is only 10, but I have stocked 11 units. So, in this case, I can sell 10 units for $300. The 1 unit, that is the 11th unit, I am not able to sell. So, the loss of that the 11th unit is $20. So, 300 minus 20, it is 280. So, what is the meaning of this 12? I have $10, I have demand is 10, but I have stocked 12 units. So, 10 units I can sell it. So, 2 units are not able to sell. So, 40. So, 300 minus 40 will be the my payoff here. Like that I have filled for this 13 also. Now, come to this category. What has happened here? My demand is 11, but I have stocked only 10 units. So, it will be only, I can sell only 10 units. So, 10 into 30, it is 300. Here what is the meaning? Demand is 12, but I have stocked only 10 units. So, the demand, the payoff is 300 units. So, now we have the payoff matrix. So, what we need to know, what should be the ordering quantity, whether the ordering quantity should be, the stocking quantity should be 10, 11, 12 or 13, that is what we are going to do. Now, to know what should be the stocking quantity, we will derive the stocking rule. What does the stocking rule says? Additional unit should be stocked as long as the expected marginal profit from stocking each of them is greater than the expected marginal loss from stocking each. If the marginal profit is greater than or equal to marginal loss, then we can go for stocking an additional unit. So, the size of the each day order should be increased up to the point where the expected marginal profit from stocking one more unit, if it sell, is just equal to the expected marginal loss from stocking that unit if it remain unsold. So, the logic, the concept for stocking an additional unit is, if it marginal profit equal to marginal loss, up to that point we can have go for having some additional units. Now, we have to find out the probabilities for which the marginal profit is equal to marginal loss. So, what we have to do? We know the probability and marginal profit. So, this will be the expected profit. So, expected profit equal to expected loss. So, what is the expected profit? Probability multiplied by marginal probability, marginal profit. What is the expected loss? Probability multiplied by marginal loss. So, what we have to do? For one value of this P, we will get a point at which the marginal expected profit is equal to marginal expected loss. So, I have multiplied by P and and marginal profit equal to 1 minus P multiplied by marginal loss. So, when you simplify this, left hand side is okay, right hand side is marginal loss minus P marginal loss, then you bring this marginal loss P minus P marginal loss to the left hand side. So, what will happen? P marginal profit plus P marginal loss equal to marginal loss. So, the P you take it outside, so it will become PL. So, the P star is probability at which the expected profit is equal to expected loss, then we are getting this expression, marginal loss divided by marginal profit plus marginal loss. Some books there is a possibility, instead of writing this way, suppose 1 minus P, if you put 1 minus P marginal profit equal to P marginal loss, what will happen? So, this will become marginal profit minus P marginal profit equal to P marginal loss. So, what will I get? Marginal profit equal to marginal P into marginal loss plus P into marginal profit. So, what will become? P is marginal loss plus marginal profit. So, if you want to know the P star, so it will be marginal profit equal to marginal loss plus marginal profit. You should be very careful. Some textbook they follow this equations. The numerator there is a marginal loss. Some books they follow this expression. In numerator there is a marginal profit. But how this formula will affect our interpretation, that I will explain with the help of a problem. So, the marginal profit we know it is $30, marginal loss is $20. So, we just now we have derived the value for optimal probability. So, that is marginal loss plus marginal profit plus marginal loss, we are getting 0.4. Now, the question is, what is the meaning of this 0.4? The value of 0.4 for P star means that in order to make the stocking of an additional unit justifiable, we must have at least 0.40 cumulative probability of selling that unit or more. Here it is at least 0.4 cumulative probability of selling that unit or more. Now, you see this, I have found the cumulative probability from the bottom, say here it is a 0.25. So, 0.25 plus 0.40 it is a 0.65. So, here 0.65 plus 0.20 it is a 0.85. So, 0.85 plus 1.5 is 1. The question is, you may ask, why did you find the cumulative probability from the bottom? Because see, in our expression, the expression which we are following, the P star equal to marginal loss plus marginal probability. But there is a reason for that. Why I have done that one? You see, I have 10 units in my hand. Suppose if I am going for 11th units, there is a 85% chance that will be sold in the market. But you see, in my hand I have 10 units. Suppose if I go for 12 units, 2 units more, there is only 65% chance that will be sold. So, I have 10 units in my hand. If I go for 13 units, so 3 units more, only 0.25 chance that will be sold. So, intuitively we can say, if you go for a small increment, there is a higher chances that additional unit will be sold. If your jump is very long, say very long, that there is a lesser chance that will be sold. That is why I wrote the cumulative probability from the bottom. This is applicable when if you use this formula, that is a P star equal to marginal loss divided by marginal loss plus marginal probability. In case if you use this equations for finding the optimal P value, for finding the optimal Q value. So, you have to find the cumulative probability from the top, that is only difference, the end result is same. Now, what we have to do? So, what is our P star value? The P star is a 0.4. So, from the bottom where is a 0.4 coming? So, this is a 0.25. So, this is the point where we are getting the 0.4. So, this has to be checked in our cumulative probability. So, as per the this marginal analysis concept, so we have to stock the 12 units. So, the optimal stocking quantity is 12 units. Now, why it is 12 units? Now, we will explain with the help of some numericals. So, marginal profit and marginal loss calculation. Suppose you see that I have 10 units, suppose you are going for 11th units. What is the marginal profit? We know marginal expected profit. So, probability multiplied by marginal profit. So, here probability is 0.85, this 0.5, this 0.85 multiplied by, we know that marginal profit is 30. So, it is $25.5. What is expected marginal loss? 1 minus P, that is 0.85, 1 minus 0.85. So, it will be 0.15. What is the marginal loss? 20. So, the expected marginal loss for having 1 unit additional, that means from 10th unit to 11th unit, if you go for 1 additional unit, the expected loss is only $3. So, it is better to go for the 11th unit because the expected marginal profit is higher. Suppose if we go for 2 units, from 11th units you are going for 12th units, what will be the expected marginal profit? So, 0.65, this 0.65 is from here, 0.65 multiplied by 30, that is the marginal profit, we are getting $19.5. So, what is the expected marginal loss? 1 minus P. So, 1 minus 0.65, it is a 0.35, marginal loss is 20. So, you will be getting $7. Here also having 12 units also, it is our expected marginal profit is larger than the expected marginal loss. Now, you see the interesting things, if we go for 11th units. So, if you go for 11th units, the cumulative probability is 0.25, marginal profit is 30. So, expected marginal profit is only $7.5. But the expected marginal loss 1 minus P 0.75 multiplied by 20, it is $15. So, here what is happening? Expected marginal loss is lesser than the loss, expected marginal loss. So, we should not go for that. So, we have keep on increasing the additional unit as long as our expected marginal profit is greater than expected marginal loss. So, that is happening if you go for only 12th units. So, that is why we got the optimal ordering quantity is 12. So far we have seen for an empirical distribution. Now, we will use the same Newsboy problem for a continuous demand. So, we are going to consider 2 type of demand pattern, that is a demand which follow uniform distribution. What is the nature of uniform distribution? See that uniform distribution will be like this. Another name is rectangular distribution. So, this is A, this is B. So, this value is 1 divided by B minus A. Okay. This area is 1. Okay. The mean of this distribution is A plus B by 2. If the demand follow normal distribution, we know that, right. So, here there will be a mean, here will be the standard deviation. See, this is bell shaped curve, it is symmetrical. So, left side area is 0.5, right side area is 0.5. Now, first we will see if the demand follow uniform distribution, how to find out the optimal order quantity. So, we have some product, see the buying cost is 700, suppose the fashion goods, say for example, shoe or something else, buying cost is 700, the selling price is 900. Okay. If it is not sold in that season, the off season price you can sell it $600. So, now if the product is not sold, the loss is not $700, it is only $100. So, first we will see what is the marginal profit. Marginal profit is selling price minus buying price, buying cost. So, 900 minus 700 is $200. What is the marginal loss? You are buying for $700, if it is not sold in that season, it will be sold for $600. Instead of 900, it will be sold at $600, the loss is only $100. Now, the question is, how many number of products would you order? Here the additional information is given, the demand for that product is following uniform distribution. So, what is the uniform distribution says? The distribution starts from 350 to 550, the mean is A plus B to 500, there is an equal chance. Why we are calling it a uniform distribution? So, if the probability of selling 350 is 1 divided by 650 minus 350. So, that equal to 1 by 300. So, the probability of selling the demand to be 350 is 1 by 300, even 351 also same, 352 also same, because you see that the probability in y axis is the probability is 1 by 300 is fixed. So, if the demand pattern follow this kind of uniform distribution, what should be the optimal ordering quantity? So, the marginal profit is $200, marginal loss is $100. First, we will find out the optimal probability. What is the meaning of this optimal probability? The probability at which your expected marginal profit is equal to expected marginal loss. So, marginal loss is 100, marginal profit is 200, so you are getting 1 by 3. So, here 1 by 3 is your optimal probability. You remember this 1 by 3, we have to, because you see that in the empirical distribution we have found the cumulative probability from the bottom. The same way here, when the probability is from right to left is 1 by 3, what should be the corresponding ordering quantity? In case if you use this formula, you will be getting 2 upon 3. So, here you can directly, so when the probability is 2 upon 3, what is the value of this demand, that we can find out, but at present we are following this one. So, what we are doing that one, we are finding probability from right to left, because the previous empirical problem I have explained that we have added we found the cumulative frequency from the bottom. So, now I am going to find out if the probability from the right side it is 1 by 3. For example, we know this is 1 by 2, because if the probability is 0.5, we know the demand is 500. From the right hand side, if it is, say if it is 1 by 3, for example, here 1 by 3, from right, you should be very careful, from right, what should be the x value. So, what I am going to do? I am going to write 1/3 of this uniform distribution. So, suppose if I am writing this, say this is 350, so this is 400, 450, 500, 550, 600, 650, 1, 2, 3, 4, 5, 6. So, I have divided into 6 equal part. So, this probability here this is 1 by 6, here it is 1 by 6, here it is 1 by 6, 1 by 6, here 1 by 6, here 1 by 6. So, I have to find out the probability where it is 1 by 3. So, if you come from this location, so this is a 2 by 6. So, 2 by 6 equal to 1 by 3. So, what is 1 by 3? So, if the probability is 1 by 3, what is the quantity? See, this is a 550. So, the optimal ordering quantity is 550 units. Suppose if I use this formula, what will happen here? It is 1 by 6, 2 by 6, 3 by 6, 4 by 6. So, what is the 4 by 6? So, 4 by 6 is a 2 by 3. So, what is the corresponding value? It is 550. Okay. So, the optimal ordering quantity is 550 units. One thing we have to know, from the probability we are finding the random values. Okay. If the probability from right to left is 1 by 3, the corresponding random the demand is 550 units. So, the optimal ordering quantity is 550 units. Now, we will see another problem where the demand follow normal distribution. So, the inventory management on perishable products. So, here the demand follow normal distribution. See, the Acme fruit and produce wholesalers buy tomatoes, then sells them to retailers. So, the buying price, Acme currently pays $20 for a box, and tomatoes sold on the same day bring $32 for a box. Because the tomato is extremely perishable, tomatoes not sold on the first day are the worth of $2 of a box. The buying for $20, but if it is not sold, it is only $2. So, this $2 is called salvage value. So, Acme has calculated that the mean past daily sale is 60 boxes and the standard deviation is 10 boxes and the demand follow normal distribution. So, the demand follow normal distribution. Normal distribution. So, as usual, so the marginal profit is, we are buying for $20, but we are selling for $32. So, 32 minus 20 is $12. Marginal loss is, if it is not sold on the same day, right. So, we are buying for $20, the loss of not selling the same day is $2. So, the marginal loss is $18. So, we can find out the optimal probability. So, it is a marginal loss divided by marginal profit plus marginal loss. So, 18 divided by 12 plus 18. So, when you simplify, we are getting 0.6. So, here what we are going to do, see the demand follow uniform distribution. What is the mean of that demand? Mean is 60. So, mean is 60 and the standard deviation is 10. Now, if the optimal probability is 0.6, we should know what is our ordering quantity. So, we know this side area is 0.5, this side area also 0.5. So, what we have to know from the right, we should be very careful because you used in the numerator, we used marginal loss. From the right, we have to find out, for example, maybe 0.6 area may be here. Suppose this is a 0.6 area, okay. We should know what is our ordering quantity. So, now the area of a normal distribution is given from right, it is a 0.6, then we should know what is this ordering quantity. There are two ways we can do that one. One is we can use your statistical table. If it is a statistical table, so if the area is 0.6, right, we should first get the z value, and you see that if you are using standard normal distribution, the value of z will be minus, you have to attach minus sign, because when you convert mu, you might have used this formula x minus mu by sigma, because 60 minus 60. So, this will be 0. So, the value of z will be negative. So, it will be whatever. So, first we have to find out when area is 0.6, we will get z value, you have to attach a negative sign there. So, we know that from that value we will get x minus mu by sigma. Mu is given, sigma is given, you have to find out the x value. But we are not going to use a statistical table, we are going to use Excel to find out the area of a normal distribution, not area of normal distribution. If area is 0.6, what is the corresponding x value? So, the x value is 57.46. Now I am going to open my Excel. So, with the help of Excel, I am going to tell how to find out the area. So, we know that the area which we are getting from the Excel is right. So, this is mean value. So, we will be getting minus infinity to positive z value if it is a standardized normal distribution. So, now we have to know if the area is 0.6, if this side area is 0.6, okay, I should know what is the corresponding x value. So, but because Excel is giving from the left side area, so if the area is 0.4, the left side area is 0.4, I should know what is the corresponding x value. So, for that purpose I am going to use a function equal to norm dot inv you see the probability is 0.4, the mean of the distribution is 60 and the standard deviation of the distribution is 10. You see that the quantity is 57. So, we are getting direct x value, the x value is 57.466. Instead of this, suppose if we use a standardized normal distribution equal to norm dot s dot inv, please see that is a standardized normal distribution. What is the probability? 0.4. So, my z value is minus, we know that z value is x minus mu by sigma, the z value is minus 0.25335. So, I should know what is the x, mu is 60, standard deviation is 10, from this I can find out the x value. So, what is the x value? Minus 2 point, yes. So, we are getting 57.4666. So, this is the ordering quantity. Now, I will go back to the presentation. So, if the area is 0.6 from right hand side, then what is the q value? So, the q value is 57.46. So, if you are using standardized normal distribution, your z value is from this one, from this z value you have to find out z value is 0.253 x minus 60 upon 10. So, we will get the, in both way you will get the same answer. Now, some of the important note you should remember. So, what will happen if the marginal loss is equal to marginal profit? So, assume that now the marginal profit is 20, marginal loss also 20. So, when you substitute here, you see that the optimal probability is 0.5. So, what is the meaning of this 0.5? In this case, we should select an order quantity corresponding to the median demand, because the 0.5 which divide the whole population into two parts. So, when it is a 0.5, the corresponding value is nothing but the median of the demand. This is the case 1. Sometime what will happen? Marginal profit is greater than marginal loss. So, if you have that additional units, suppose you will be getting more profit than the marginal loss. What will happen? Suppose I have kept marginal profit is very high, say 1000 units, $1000, and marginal loss is only $20. So, when I substitute here, what I am getting, see the P star is very low, 0.01. So, what is the meaning of 0.01? Assume that this follow normal distribution, for example. So, from right side area, if it is 0.0196, so I will get some Q value, that Q value is very higher value. So, what will happen if the marginal profit is higher? So, in this case a larger order quantity will be recommended. So, what will happen? The reverse of this. So, the marginal loss is greater than marginal profit. You see marginal profit is only $20, just I reversed, marginal loss is 30. Now, the optimal probability is 0.98. So, what is the meaning of this 0.98? So, from the right hand side it is 0.98. So, this side area is 0.98. Obviously, we will be ordering very small quantity. So, in this case a smaller ordering quantity will be recommended. Dear students, in this lecture I have explained the famous problem called Newsboy problem. The Newsboy problem is a single period inventory model with the probabilistic demand. We have seen three types of demand pattern. One is empirical, uniform and normal distribution. By considering these three type of inventory pattern, we have suggested the optimal ordering quantity. The next lecture we will be discussing about multi-period inventory model with probabilistic demand. Thank you very much.